Hello YouTube. So if you've been watching my videos, you probably know that I completed the 6502 computer from Ben Eater's guides, but he continues to add on a PS2 keyboard to serve as user input, and it's really cool. But I don't have a PS2 keyboard, nor do I want to buy one, and a USB keyboard, yeah, not ready to tackle that yet. So then I decided to try my own form of input, and I decided, hey, why not try Morse code? I know how to use a shift register. And then I had a great idea, which was to use a resistor capacitor charging circuit like this one over here. So if I were to press the button, then it would slowly charge up, and then if it's a long press, then it would charge up to 5 volts, then it will count as a logic high. But if it's a short press, it would only charge a little bit and drop very quickly, and it wouldn't reach the threshold of a logic high. So that was my original idea, to use a circuit something like this, where the ideal would be a slow charge time and a fast discharge time. But I didn't really get to how to do this, so in the end I landed with a signal something like this. And I did try to implement this, but it turns out that when you put the specific circuit that I was trying to do, and especially since I'm building on breadboards, there's lots of stray capacitance. And what that does is it creates a tank circuit. And what a tank circuit is, it's a circuit that will create oscillations. And I'll try to link it maybe in the top right corner if I can figure out how to do that. But if I can't, then you don't see anything here, then it's in the description. I'll link a video explaining why a tank circuit creates oscillation. But then this tank circuit, it creates chaos in my system, and in the end it didn't really work out as I expected. So then instead I tried using a binary counter. This chip is the SN74HC161. That's a binary counter. And what the binary counter does is when I trigger the button, it will enable the chip and it will start counting clock pulses from this astable 555 timer circuit. And then once certain timing has reached, then it would trigger this signal that triggers the LED. Wait, no. Oh, then it would count as a logic high, and then it will get latched into the shift register. I'll show you a block diagram which I got from my sensei, my master. Yeah, he was the one who recommended using a binary counter for this. So here you can see that if I were to short press, the LED doesn't turn on, but if long press, the LED does turn on. So right now I actually have a 1 latched into the one of the registers in the shift register. I think it's in the shift register inside the shift register. Wait, no. Yeah. So now when I short press, then it gets shifted in. And then you see, every time I short press, it actually moves over by 1. So then a long press would be something like this. And you can see that this is actually a binary counter, because if I just hold down on the button, you can see it actually toggles like this. But it serves its purpose. I can input whatever I want. So if I want a 10 10 10 10 alternating, then I would just do this. Yeah. So then this can serve as a serial input almost. I know all these codes are based off of Morse, like A or B. But then at some point, the certain codes will mix up with each other. I cannot tell which letters apart. So then I have to alternate, I have to change the codes a bit, and it ends up becoming more like my own form of serial input and not really Morse code anymore. But that is fine. Alright, so now I explained my shift register, this serial input, my form of input to the 6502. Now I'll cover the software side of how I handled the interrupts and how I read the data. Hello, this is Aiden speaking to you from his laptop. I'm screen recording. Woohoo! Okay, so I implemented essentially the same thing Ben Eater does with his keyboard write pointer, read pointer, and the keyboard buffer. The loop, the main function of the code, is also the same. So yeah, I took a lot of inspiration from his PS2 keyboard video. I'll link it in the top right corner if I can find a way to do so. But yeah, even the key maps is the same, you see. Except I can only use like 16 bits of space here because for one, I only have 5 bits of input to use. I could make it more, but you know. And then you see these two like extra spaces here with the question mark. I added in a shift left function, which is this 01010 over here, and this shifts the cursor to the left, so it's essentially a delete function on your keyboard, or backspace. Yeah, I decided this was a necessary function, and also new line, which is this. It would be nice if I could add in shift display as well, but you know. Anyway, yeah, that's about it. You see there's lots of like commented out things here. What I did was, instead I didn't know there was this function, this command of shift the cursor left by 1. So I tried to keep track of where the cursor was in the LCD, and I tried to do that by keeping track of the LCD's DD-RAM value, but that didn't work out. And then I asked Reddit, and turns out that's just a simple function. So yeah, thanks for watching. See ya!